Hello and welcome to MathandBolt. So today is our first lecture on Calculus 1. We begin our very first topic on functions. So let's try to understand what functions are. Functions are usually something that is going to relate an input and an output. So you can write it as a function relates the input to the output. Now what does it mean? Let's try to understand with the help of an example. Let's say we have a machine. It could be a calculator of some sort or some kind of machine, and it has got a rule. The rule is such that if we plug in the value, so this is the input, and it's going to give us a specific output. What I mean by that is, let's say we plug in the value 2, is going to work on this particular number. Some kind of rule is being applied to this particular number, and it gives us the output 4. Right? Let's say we have another number 3, and we feed it into this particular rule box, so that's going to give us 9. If I take in the number 5, put it through this particular rule box, that's going to give us 25. Now we can immediately say that, let's say if I take any random number x, pass it through this box, which applies some rules to it, and that gives us x squared. So this is what we have done. We have actually defined a function. So a function is just like a machine, and this particular machine, which is the rule box, it has got some input fed to it, and it's going to apply some rules to it, and according to the rule is going to give us a specific output value. Usually the most common way of writing a function is f of x. It's read as f of x, or in more general as a function of x. Whenever we talk about functions, there will be always 3 things that comes over and over again. So the first thing will be, we'll always need an input. That's number 1. Then we're going to have some kind of rule that is assigned to the input, and after that we are going to get an output. Let me now introduce the idea of a variable that is going to represent a function in a nicer fashion. So we've already mentioned that f is a function of x. Here x is usually the input. Usually, in most cases, x is considered as the input. Then what happens? This rule is the rule f. Now this particular function or the rule applies on x, so that's when we call it f of x, and that is going to give us the output. So generally the output is a function of x, f of x, and sometimes it's also referred to as the output y. Right? So that means we can say y is equals to f of x, where y is a function of x. So let's now write it down. So we can say a function usually given by f of x or y. So this is a rule that is going to assign exactly one value, we call it y, for each of the input values, that is x. What I mean is, this y is very unique. It's unique to the value of x. For example, in this particular rule where we have stated that our function f of x is equals to x squared, so this is our function, so it's very unique. So that means if I take the value of x as some negative number, negative 3, then f of negative 3 is going to be negative 3 whole squared, so that is going to give us 9. So this is a very unique value. There is no arbitrariness in this value. This is going to be a single unique value. If that happens, then we say this is a function. The input x is usually the independent variable, whereas the output that we obtain is the dependent variable. That is because we have defined a function as f of x, which is y. So we can say y is a function of x. That means y is dependent on the values of x. So like in our previous example, we have considered y is equals to x squared. So that means x can take, here x can take any values, any real values. It can take any real values. We can take, for instance, x can be positive, it can be negative fractions, it can be rational numbers such as square root of pi, it could be the exponent e, and so on. And when we plug this particular values of x, then we're going to get a very specific value of y. So for each unique value of x, we're going to get a unique value in y. That's why y is totally dependent on the values of x. So y is a dependent variable. Now there is also another name for it. The x or the independent variables are generally referred to as the domain of the function, and values of y are referred to as the range of the function. So let's write the definition. So what's a domain? A domain is referred to as the set of values of the input, that is x. So that will be our domain, and the range will be the set of values of y. That's it. So that will be the range. Now I'm going to introduce to a very powerful visual rule that is going to tell us whether if a relation is a function or not. Because not necessarily if we give a relation, it does not necessarily mean that particular relation is also a function. Let's understand this particular idea with the help of a few graphs. Let's say we have a graph of some sort and it's given by this particular shape. Now the question we want to ask is whether if this graph, this is some kind of graph, if this is a function or not. What we're going to do, we're going to use the vertical line test. All we have to do is like draw some vertical lines, random vertical lines we need to draw, and we need to check whether if this particular vertical line crosses the graph at exactly 1 point. So here we see that it is crossing the graph at exactly 1 point. Let's draw some other vertical lines as well. So this particular vertical line is intersecting the graph at a single point. So wherever we see that wherever we draw vertical lines, they are all intersecting this particular graph at a single point. Even if we look at the y-axis, so y-axis will be a vertical line, so that's intersecting the graph at a single point. So this particular graph, so this graph of our function f of x passes the vertical line test. So f of x is a function. Now let us consider another graph. So let's say we have this upward facing parabola. Most probably you have encountered this particular function in your pre-calc class under conic sections. Now we want to check whether if this particular graph represents a function or not. The equation of a parabola is y, which is a function of x. So this is equals to x squared. The question is whether if this is actually a function or not. So what we will do, we'll always draw vertical lines. So we have one vertical line, and we see that this vertical line is crossing the graph at one single point. Then let's draw another vertical line. So we can draw multiple vertical lines, and we'll see this is always going to intersect the graph of y equals to x squared at only a single point. So that means the graph of f of x is a function as it passes the vertical line test. Let us consider one more function. So this was the upward going parabola. Now we're going to consider a right facing parabola. So a right facing parabola is a parabola which is facing the right hand side, and its vertex is at the origin, and the axis of the parabola is the x-axis. So this function f of x is given by y squared. Now the question is this a function or not? Now if we draw straight lines, we'll see that this particular vertical line is going to intersect the parabola at 2 points. So we can draw multiple vertical lines. We'll see that it's always going to intersect the parabola at more than 1 point. So that means by the vertical line test, the function f of x equals to y squared is not a function because it fails the vertical line test. Let's try a few more examples. So here we are provided with 3 graphs, and our objective will be to find out whether if they are function or not. For each of them, we'll apply the vertical line test to check whether they are functions or not. The first one is the exponential function given by y is equals to e raised to the power of x. So what we'll do, we'll draw vertical lines. So it crosses the graph at a single point. We'll draw another vertical line. There's also crossing the graph at a single point. So that means yes, passes the vertical line test. So f is a function. The second graph, this is the graph of the logarithmic function. So we have y is equals to natural log of x. Now here again we see that if we draw vertical lines, this is also going to cross the graph at a single point. No matter where we draw, it's always going to cross the graph at a single point. There's no need for drawing vertical lines here because the graph does not exist. So we'll restrict ourselves to drawing vertical lines for values of x greater than 0. That means on the positive x-axis only. Now this also passes the vertical line test. So immediately we can say that f is a function. F is a function. How about the third one? This is the circle. So this is given by x squared plus y squared is equals to, let's say, some radius 1. So let's say this is a unit circle of radius 1. Now does this graph represent a function? Definitely no, because when we draw vertical lines, we will see that intersect the graph at 2 points. Wherever we intersect, wherever we draw vertical lines, it's going to intersect the graph at 2 points. So this is not a function, fails, or we'll write it fails the vertical line test. So f is not a function.